Good morning, everyone. Am I audible? You can hear me, right? Okay. Yeah, we'll start. Um, I'm sharing my screen. Is that visible? Screen? Screen is visible, right? Yes. Okay. Thank you. So, last week and before that, we did few experiments related to blinking an LED. Our discussion went after that experiment to variables and different data types. So these are the variables and the data types we discussed. Like we have a chart of different variables with its type modifiers. I will tell you what it is. So variables means we can define memory inside a microcontroller in two different ways. One is constant, one is variable. So constant means it is permanent. Whenever you create a variable inside your program, throughout the program execution, you can't change the value of that particular variable. So how can we define that constant? That is done by that is did by using hash define. So hash define is a directive. So with hash define we can uh, create a constant. So I'm going to define a value called pi. Its value is 3.14. It is not going to change throughout the program execution. Also you can define a similar variable like this. So uh, not variable, constant like this. Also you can do constant in a different way using const variable. We will discuss it later when we are going to use that. So sometimes we define variables and constants. So keep in mind that both are memory locations which we are going to use um, when we are writing a particular code. When we need some memory location to store the data um, or information. So these are the variable which can have different data types. So short int means its size is 2, which can hold a decimal number, counting number from minus 30 32,768 to plus 32,768. So unsigned means positive. If you are not keeping unsigned in front of a particular data type means int. These all are data types. Okay. So in front of any particular data type, we are keeping unsigned. It will become if you are keeping unsigned, it will become positive value only. You can check in this range. Wherever you can see unsigned, it becomes only positive. Okay. So these short, long, unsigned, or these kind of things, keywords in C are called type modifiers or type qualifiers. Okay. So today we will discuss something deeper into the microcontroller port architecture. So before that, I will go to our code. Here in our code, we wrote a few lines called um, initialization. So this one line is called initialization. This is port initialization. Okay, port port initialization. So what is TRISB? We are going to check that. We are going to learn that. So inside the microcontroller datasheet, we have a particular section called IO ports. So there are too many things to learn here in this datasheet. We are learning it one by one. So what is port? Port means a particular peripheral of uh, microcontroller which helps the microcontroller to collect the data or to send the data to outside world. Collect the data from outside world and to send the data to outside world. So this is port B. Likewise, we have different ports. I will show you one pin diagram. So this is the pin diagram, or else you can see it in our schematic also. So you can see RA0 to RA5. This is port A. Our microcontroller have many ports. It starts from port A. RA0 to RA5 is the pin numbers, pin names, and RE0 to RE2 is port E. Likewise, likewise RA0 in port A, RB0 is in port B, RC0 is in port C, RD0 is in port D. Likewise, 1, 2, 3, 4, 5. 5 ports. We have 5 ports available in our PIC16F877A microcontroller. So our discussion is focused on port B today. Okay. So if you want to learn more about port B, we need to come to our PIC16F877A microcontroller. Inside the bookmark, you go to IO ports, then you select port B and TRISB register. So what they are telling, port B is a 8-bit wide bidirectional port. The corresponding data direction register is TRISB. Setting TRISB will make the corresponding port B pin an input, putting the corresponding output driver in high impedance mode. So this is port B's internal diagram. So whenever you want to make a particular pin in pin an input, you have to make the corresponding register value to 1. This is what they are telling. I will write a code. So this is an LED blinking code, right? So I am going to write a particular code for blinking an LED when the switch is pressed. I mean, it should happen like this. When I press the switch, when I press and hold the switch, then only the LED should blink. Okay. Whenever I press the switch, then only the LED should blink. So here we are going to learn both the input and output configuration of a particular port, particular port and particular pin of a microcontroller. So let's see how we can do that. Okay. For that, I need to know where this particular switch is connected. I am modifying this. I am connecting it to RB1. Okay, RB1. So RB1 is now became an input to the microcontroller, which reads the switch, and RB0 is output to the output of the microcontroller, which writes to the LED 0 and 1. If we write 0, LED will turn on because 5 voltage is here. Voltage always comes from high voltage to low voltage. 0 if we write, it will turn on the LED. 1 if we write, it will generate 5 volt. Here and here it is 5 volt. So voltage difference is 0. There is no current flow. Hence no LED will blink when we have 1 written here. Okay. So let's see how we can write it. So for simplicity, for easily writing the initialization code, uh, I usually do a method called creating a register. So what they told port B is an 8-bit wide bidirectional port. The corresponding data direction register is TRISB. Okay. So this is TRISB register. The size is 8, they told. So I am making an 8 small boxes here. Now it become 4. Now it is 8. Okay. So what I did in the circuit, RB0 is output, RB1 is input. Keep in mind, they are telling the corresponding data direction register. Setting at TRISB bit 1 will make the corresponding port B an input. Clearing TRISB bit will make the corresponding port pin an output. So I am going to do that. The corresponding register, this is the corresponding register of RB0 pin. Okay, B0, I am writing B0 only. This is B7, 7th pin. Okay, so our discussion focus only RB0 and RB1. So RB0 is output. So I have to write 0 over here, and RB1 is input. I have to write 1 over here. Remaining registers we are not least bothered, so we can think the remaining registers are 0. So I am going to take this value 8, 6 zeros and 1 and another 1 0. If you open calculator and go to programmer, choose binary 1 0, you will get a hexadecimal value 2. Okay, 2. So you can write a code like this. Tris b equal to 0x2, which will make port B pin number 1 as input, port B pin 1 input, pin 0 output. Okay, so this will configure this particular line configure port B. Port B has been configured. So now we have to read that port pin. So the read the port pin. Here we with this line port B equal to 0x01 and port B equal to 0x00, we are writing a particular value to port B register. Okay, so let's see what they are told remaining. So clearing tris B will make corresponding port B pin an output. Okay. There are a few things they are telling. We will discuss about those pull-up things and all little later. Interrupt. Okay. So this is the internal diagram of that particular pin. So suppose we are discussing about RB0 pin, our LED going to connect through here. So internally we have a particular D flip-flop kind of thing. So data bus will get the data from here. So it will come through this particular D flip-flop. We have Schmidt trigger kind of thing. Um, Tris registers will help the Schmidt trigger to work. According to that, we will get the output. Also, sometimes when we configure TRISB register, these pins will get into high impedance stage. If we configure it into the what we say as an input, the pin will become an high impedance input pin. Okay. Also, you can see the pin is monitored via this this flip-flop. You can see the pin's voltage states are monitored through this way. Input is taken through this way, output is coming from this way. Okay. So let's go back to the code. Then one more initialization is needed. We need to make sure that port pin initial status. What is mean by port pin initial status? I am going to write a particular code here, that is port B equal to 0 0x 01. So if I write this particular value 0x01, I'm putting it into x 0. I'm writing 1. So binary, you can see the least significant bit became 1. So if I am writing a particular code like that, what will happen? This pin will become high. So what I wrote there, port B equal to 0x01. So 0x01 means remaining all the pins will become 0 and this pin will become high. So this ensure that at the time of microcontroller turn on or the initialization, this pin becomes high, which ensures this LED is off at that particular moment. You will understand it little later. So initialization time, LED off. Okay, I am writing LED off only. LED off. Also, we need to make sure that this particular pin is high. So I have to make sure this particular pin also high. So I need to write 3 over here, not 1, 3. So what will happen if we write 3? Hexadecimal 3, uh, not 1, 3, only 3. The least significant, the two least significant bits will set to 1. So this will make sure that these two pins are in high state, not in low state. Make sure that it is in high state and the LED will be off. Now I will discuss about switch and its basic operation. You know how switch is working, right? It makes connections. So what happens? I wrote a 5 volt here through this particular initialization. I mean port B pin, both are in 5 volt. So here you can see a 5 volt. I will compile this code and I will show you. While writing the code, you try to keep the tab spaces uh, properly. It will help you to debug your code easily. So there are many coding practices we need to discuss. So let's compile this code. Yeah, it got compiled. Now let's see. So here I am taking one voltmeter to measure the voltages available on the pin. So I took one voltmeter and I am connecting its positive to this plane, ground to this plane. So here you can see the initialization time voltage at RB0, sorry, RB1 is 5 volt. When I press this particular button, you can see this particular voltage at RB1 becomes 0. So this is what happens when the switch is getting pressed. It you know that, right? We have a voltage here. So whenever we press the switch, there would be an electron flow through this particular line, and the voltage gets uh, grounded. I mean, it becomes 0. So this is what we are going to uh, check. What microcontroller will always monitor this particular pin. Microcontroller will always monitor this particular pin whether it is becoming 0. Then what it will do? It will do the blinking process. It will do the blinking process. Let's see why my code is not working. RB0 equal to 0. What b equal to 0 x01. Not RB0, it should be RB1, right? So yeah, this is RB1. So we are checking RB1. Initially the code I wrote, it was RB0. The monitoring pin is RB1. So we need to write RB1 equal to 0. Let's see. Uh, so when you write your code, keep your brain focused. Um, on the task which you are doing. Yeah, right now you can see the LED is blinking. I am keeping the switch in on position. Now you can see the LED is getting turned on and off. So I will explain the code again. So what happens here? We initialize the port and initializes the pin also. Made sure that port pin is high all the time during the initialization. So this is the initialization phase. Controller got initialized. During the initialization and after the initialization, it is both the pins are in high state. RB0 is in high state, that's why LED is not turning on. RB1 is high state, which ensures that this particular pin has enough voltage um, to monitor the changes. The changes are getting monitored by this particular code. This code, if RB1 equal to 0, what it is doing? If RB1 equal to 0, it is continuously checking for this particular pin, whether it is 0. If it becomes 0, I mean when I keep this switch in on condition, then it becomes 0, right? Yeah. So this code checks like that. If RB1 equal to 0, it is writing a particular value to port B. What is that particular value? This 0x01. I will modify this code uh, like this. Instead of port B, I am going to write RB0. RB0 equal to 0. RB1 equal to 1. RB0 equal to 0. RB1 equal to 1. So what it is doing when a particular button is pressed, RB0, the pin will become 0, means ground potential. After a particular delay, the RB1 will become 1. 1 means, you know, right? 5 volt, which will turn off the LED. This is 0 volt, which helps turn on the LED. You can see. From next session onwards, I will reduce the deeper discussion once you guys understood that basics properly. So this is what happening. You can see the voltage changes over here. Uh, these changes are done by this particular code. RB0 equal to 0, RB1 equal to 1. You can see the changes 0 and 1 which is happening here. So we wrote a particular line, this conditional statement. There are many these kind of statements are called what it is called. Wait, just a second. So conditional statements, yes. So if else kind of thing. In the control structures we have these things. So we will learn these kind of conditional statements in deeper with the deeper C learning. So we learned variables and constant data types in C. Now a part of control statements we learned if. Okay, so now I will tell you about this particular loop. Okay, so we have one loop here. It is while loop. It is while loop. So suppose you have any embedded system device. For an example, I am taking your mobile phone. So your mobile phone software is in continuous. Wait, just a second. Someone is pinging me. Paudan, you want to ask something?
Yeah, Shikumar. I'm a
Yeah.
bit lost actually with
Mm.
this Trisby and Portby.
Okay. I will explain. So, our microcontroller has many ports. Okay, RA0, RB0, RC0, RD0, RE0. So our intention is to create a hardware which blinks an LED whenever the switch is pressed. So our intention is to create a hardware and a software with a functionality of blinking an LED when the switch is pressed. So how the hardware is created? The switch is connected to RB1, okay, and LED is connected to RB0. These two hardware, input device and output device, lies in port B register. So our interest of discussion is port B only. So when our discussion is in port B, we are going to the data sheet and we are going to the port B section. There they clearly written port B is an 8-bit wide bidirectional port. The corresponding data direction register is TRISB. Okay, so TRISB is one of the register we need to configure with the help of our program. Setting a TRISB bit, there are so many TRISB bits, TRISB0, TRISB1, TRISB2, TRISB3, TRISB4, 5, 6, 7. Okay, setting a TRISB bit equal to 1 will make the port B pin, corresponding port B pin an input. So in our case, this position belongs to switch. Okay, this position belongs to LED. Correct, right? How then? Till this point, you have clarity, right?
Mm-hmm.
Okay. So 0 belongs to LED. You can see that RB0 is connected to LED, RB1 connected to switch. So this belongs to switch, this belongs to LED. So what they are telling in the data sheet, we have to make that particular bit 1 for making the pin an input. So here this portion should be 1 because switch is connected to at this portion. So we are writing a 1 here and this is LED. We have to make write 0 here. So that's why this particular 2 bit position got created, how it got created. So remaining, we are not bothering about that remaining values. So we are making all those remaining bit position 0. So suppose we convert this particular value to hexadecimal. If you are not interested in converting, you can write a long value in the code itself. So you have to write it like this: tris tris b equal to 0b. I mean 0b means binary. Then you can write all those lines 0 0 0 4 0 double 0 0 1. This is difficult to maintain the code. That's why I am converting that binary value to hex value. This is what we have to write. And this binary value to hex value. If I convert this particular binary value to hex value, I am going to get this particular value 0 2. Okay. We learned in basic digital electronics 0 0 means 0, 0 1 means 1, 1 0 means 2, 1 1 means 3. So these binary values, our port size is 8 bit, so we will have 8 bits. Okay, so 8 bit, when we configure all the 8 bit, we will get a hexadecimal value ff, which belongs to 15 in decimal. Okay, so likewise, we are getting this value. So this is how we got this first initialization, tris b equal to 0 2. Okay, so this line we wrote like that. Now next line, port B. Pawan, is that clear? How we initialize the tris register?
Yeah, yeah. I mean, this is clear. I'm a
Okay,
bit confused, like why we have crispy and why we have port B actually. I'm
okay,
confused.
okay, okay. So uh, there are so many internal details, like why we have tris B and why we have port B. Port B is a data holding register. I mean, whenever we want to write a particular data to port B, we are controlling port B register. Actually, the name port B is port B's real name. Okay, so port B and tris B register. Actually, port B has two register. Just I will go to paint. Suppose we are discussing about port B, port B. It has two registers to check, one and two. First register name is tris B. Second register name is that port's name itself. Okay, port B. So port B has two registers, tris B and port B. Port A has two registers, tris A and port A. Port C has two registers, tris C and port C. Likewise. So what is the use of tris B and port B? So tris B is used to configure the configure port B's pins. Configure means whether it is input, whether it is output. We have to configure it with the help of tris B register. And then what is the help of port B register? What is the use of port B register? Port B is used to read and write, read and write to that particular port or pins. Suppose we write a 0x01 in port B register, it will reflect over here. It will reflect over this position. This position will become 1 if we write 0x01. If we write 0x10, it will reflect over here. Okay, so this is a register which is used to control, which is used to write or read. Suppose we want a data from pin, all the pins, we can read it like this. Suppose we want to read a particular pin, we can write a code like this. We will create a variable called y variable is got created, which is of type character. Y equal to port B, y equal to port B, which will help you to read all the values to y. Now the y will become what it is available in port B. Suppose we want to read, suppose we have many sensors connected, digital sensors connected to port B, and we want to read all the sensors at a stretch. We will do like this: y equal to port B, and we will examine y, what is there in a particular register with the help of different coding styles are there. Later when we learn sensor interfacing, you will get to know how we are reading the particular registers. Okay, here also we are reading it, but it is bitwise reading. Like we are directly reading the particular bit, we are directly reading this particular bit, rb0, sorry, rb1. So rb1 got readed. So port B is a particular register which is used to write or read from port B. So then what is port A? Port A is a particular register which is used to write values to port A and read from port A. Okay, is that clear, Pawan?
Yeah, if I understood it correctly,
Hmm.
so this Trisby is only to initialize
Not to
and
initialize, Pawan. It is used to control the behavior of the port. whether it is input or output.
That's what
Mm.
to configure it as an input or output. That's
Yes,
it.
yes, yes.
So the other register like port B, which
Mm.
will write on top of that
Mm.
uh, to read and write, right?
Yes, to read and write a particular pin or entire register.
Okay.
Yeah, okay, yeah. So after that, yeah, I'm deleting this code. Mm. So we were discussing while if you are not understanding, you can always turn on your mic and ask. Don't try to raise your hand or uh, like that, because I am not seeing this screen when I am taking uh, the session, like explaining the code or this thing. So directly turn on the mic and interrupt me. We can discuss always. So what happens? This is a while loop. So what I was telling, your device is on any of your embedded device is always in while loop. How can I say? I will take one mobile phone. Yeah. So so this is an old mobile phone. You know how to lock it. We press this particular button and star button. It will get locked. So unlock, we will press the same button and the star button, it will get unlocked. So this mobile, once it is powered on, it is doing so many tasks. It is waiting for call, it is waiting for messages, it is waiting for someone to press its keypad. So it is doing so many tasks. So these all tasks are in a loop. Loop means it is a never ending process. I mean, this while loop, it is never ending. Whenever you press the key, whenever the system is powered on, it is waiting for a key press. Whenever you press it, it will turn on the LED. Whenever you release, it will turn off. uh, Not turn off, the process will turn off. Okay. Okay, just modify the code for better understanding. I will cut this code, so we will learn the else part also. We'll write the else part. So the code got changed. I'm removing the delay. So you might be understanding what is happening, right? So whenever the button is pressed, LED will turn on, else LED will be off. So this is the code. Okay. Now let's see how the code is behaving. Later when I pressed, the LED was blinking. Now it should turn on. It is not turning off. Why? RB1. We should focus when we write the code. It should be RB0. Okay. That's why it is not working. So whenever we write any code, not only embedded system code, if you want to work that particular code, you need to focus too much. Okay. So yeah. So when I press, it is turning on. When I release, it is turning off. So this is the code. So I was discussing about while one. So any embedded system in the world is working inside a while loop. So outside the while loop, you can see few codes, right? Initialization of a variable, initialization of port. These two lines are initialization of port B. One is configuration and one is making sure the initial loading the initial values to the pin, okay, and ensuring that these pins are in right state. Suppose there are detailed discussion needed regarding this particular 23 line. uh, I will discuss that. So what is while loop? You understood, right? While is a infinite loop. While one is an infinite loop. If we write something, a constant is needed. That's it. Next class we will discuss conditional statements and loops. Only that class will become theory only. So this is why I hesitate to discuss those things. So in that particular class, next session, we will discuss entire these two section. Okay, entire these two session, the theory part only. The, entirely we will discuss this theory part. Then we will write the start write the embedded system code again. So while one, just keep in mind, it is an infinite loop which helps the microcontroller to uh, do the things infinitely. Infinitely means it's a never ending process. Inside this while one loop, it is a never ending process. It will always check for the RB1. Okay, it will always check for the RB1 pin and modify RB0 accordingly. RB0, if RB1 equal to 0 is equal to 0, microcontroller is understanding that someone pressed the switch. Someone pressed the switch and this particular pin RB1 is coming to low voltage. So someone has pressed the switch and I have to turn on the LED. This is how microcontroller thinks when we write a code like this. If someone release the pin and the switch is not pressed, microcontroller thinks that I should turn off the LED by making RB0 equal to 1. Okay. So this is what all I want to discuss today. So there are much more to learn in this small code itself. So we will learn it and we will write bigger codes later. Um, so any doubts there? Sayuj, is that clear for you? Today there are less people, many of Sayuj.
Yes, sir. It's clear.
Okay, okay. So write a code and try to draw a circuit diagram like this in your Proteus, and try to write a particular code which helps you to read the switch and control the LED. Send me that picture in WhatsApp before next class. Just write the code and send me the picture which you draw on your Proteus. Okay. Um, yeah, that's it for today. Uh, we will wind up. I recorded this session because many people have exams, so they requested me to record it, the session. So records I will later I will post on YouTube. You can watch and um, think about it. Uh, I want to say one more thing. With the help of this code, if you understand it properly, you can do many projects. Only many projects in this embedded system world is run with the help of reading the microcontroller's input pin and writing back to uh, output pin. So you can do many small small stuffs like water level controller. So many small projects you can do with these very basic knowledge. Okay, reading reading a particular data from a sensor. Suppose this switch is a water level sensor. You can read its status and turn on a particular motor. You can do all those stuffs with the help of this small code understanding. Okay, from next class, next class I will discuss all these things in detail. We will write small codes and its execution. Suppose we are good enough, suppose we have good enough understanding till here, we can do so many things. Like we can learn deeper things in this session. Where is that? Okay. So we can go to internal details of the microcontroller. So yeah. Well then, thanks for asking those questions. Yeah, it made me explain a bit deeper. Yeah. See you all. Thank you. Bye.
Thank you.